Assalamu alaikum students. Today I am recording this video to prepare or to revise with you the end of term one mechanics exam. So in front of you, the screen is shared. You can see we have the front page and then we go to the MF19 formula list, which will be provided to you also in the exam. So these are the four equations of motion. The fifth equation of motion is not here, but you can write from here. It is S is equals to Vt minus half At square. F is equals to Ma, the Newton's second law. It is not provided here. And F max, the limiting friction, it is equals to mu r. Mu is the coefficient of friction, and r is the normal reaction. And momentum, it is mv. This formula is also not given to you. So you need to memorize limiting friction formula, momentum formula, Newton's second law, and one equation of motion which is not provided in MF19. Now, chapter number 5, if you look at that, we have Newton laws, how to resolve components of weight when the weight is placed on a slope, when multiple forces are acting on a body, and last but not the least in this chapter number 5 is connected particles. The quick reference for you is your mechanics book and all the worksheets which we did in the class and as a homework given to you. We can have chapter number 6, friction, rough horizontal surfaces and inclined plane. Last is momentum and collisions, in which Coulomb situation is also included in the final exams. Many resources are mentioned over here for you if you want to do some extra practice. Don't forget, you need to bring your calculator, FX99 via EX recommended to bring in the final exam. Total marks of this exam is 40. But 10 marks are already given to you. So that test in section B has been already taken. So 30 marks. Its final exam will be. And the value of G is very important here. The value of G will be 10 meter per second square. So let's start the revision, guys. So the first question is a wooden block of mass 5 kg. So this is the mass 5 kg is rest on a smooth horizontal table. So when I say smooth, it means that there is no friction. And the mass is 5 kg, so the weight will be 50 newtons. 1.6 meters from the edge of the table. So I can make a table for myself. And this is a block. Okay. So the block is pulled directly towards the edge of the horizontal. So this is the edge of the table. And the guy said it is 1.6 meters away. Mass is 5 kgs. So weight is 50 newtons and it is balanced with the normal reaction. So when you guys pull it, definitely a tension will be produced in the string. When we use a string, so the tension will be seen here. Okay, so tension is applied in this direction. So tension is applied in this direction. And then the tension is 1 Newton given by the examiner. Calculate the time taken to reach the edge. So we need to find at what time it will reach at the edge of the table. Now, there are two important things in this question. First, we don't have acceleration because the block is moving. So how can I find acceleration? First, I need to apply Newton's second law, which is F net is equals to MA. F net is the tension minus friction. Is there any friction? No, it's a smooth surface. So if a smooth surface, friction is 0, is equals to MA. Tension is given to me 1, friction is 0, mass is 5 times A. So guys, acceleration I found 0.2 meters per second square. Wow. Now acceleration is found, which is 0.2 meters per second square. The block was in the rest position, so U is equals to 0 meters per second, right? Acceleration found, U found, and the distance is already given of the block from the edge. It is 1.6 meters. So three things are known to me. What actually I want to find the time it will take to reach the edge of the table. So which equation of motion will be suitable for me? Obviously, guys, S is equals to ut plus half a t squared. So S is equals to U is 0 times, and S is given to me 1.6, and 0 t is needed to be found. Half acceleration we found 0.2 times t squared. So now 1.6 is equals to 0.1 t squared and 1.6 over 0.1 t squared. So t will come to me equals to 4 seconds. So the question was not very hard. So two things are important for you in this question. So the Newton's second law will give you acceleration. And then the equations of motions, will be helpful for you to find how much time the block will take to reach to the edge of the table. Let's go to the next question. In the next question, he said a porter at a railway station is dragging a suitcase of mass 82.5 along the platform with an acceleration. So acceleration is provided to me. The horizontal force that he exerts is 117 newtons. Frictional force we want. So let me make a horizontal ground. He's applying the horizontal force of 170 newtons. Friction is there, but friction is required. Mass is 82.5 kgs, so 825 newtons weight. Normal reaction is R. We don't need it, but Newton's third law says reaction is equal to 825. Now, acceleration is given to me 0.175 meters per second square. Newton's second law F is equals to F net is equals to M times A. F net is 170 minus friction, and mass is 82.5. Acceleration is 0.175, and I want friction. So let me use my calculator, and you also use your calculator. Here, I would suggest student needs to use equation solver to get the answer quickly. So 170 minus friction, you can write in the calculator as X, and then equal sign 82.5 times 0.175. Okay, shift solve, and my calculator gave me 155.56, but we have to give the answer to three significant figures, so my answer is 156. So friction is 156 newtons. Now we come to the question number 3, guys. In question number 3, he told us the particle has a mass 0.5 kgs, is being pulled in a straight line by a along a horizontal surface by a string parallel to the surface and the acceleration is 2.8 meter per second square, when there is a frictional force of 4 Newton that opposes the motion of the particle, find the tension in the string. When the particle is traveling at a speed of 3 meter per second, the string breaks. You remember, guys, when the string breaks, at that time, the tension should be put equals to 0 Newton. But that is the second phase of the motion. Calculate how much further the particle will travel before coming to the rest. So it means that the final velocity will become equals to 0. So this question has two phases. First, when the particle moves from here to here, at this time, the particle is connected with a string. And this is the phase when the string breaks. If the string breaks, then the tension will be 0 newtons. But here tension is intact and it is there. Okay, so tension I want to find. Did he mention that? He said, like, find the tension. Yes, we want the tension when the 2.5 kg particle was pulled. Acceleration was 2.8 meters per second squared. Frictional force is 4 Newton. Okay. Done. And when the particle acquires the speed of 3 meters per second, at that time, tension will be 0, but frictional stays the same. Frictional will be 4 newtons. So firstly, guys, my request is to focus only on this part. Apply Newton's second law. Newton's second law says that tension minus 4 newtons is equals to mass times acceleration. Now, try to calculate your tension by using your calculator, equation solver. So x minus 4 equal sign 2.5 times 2.8, shift, solve, and calculator gave me 11 newtons. So 11 Newton is acting on the string. Now the string breaks. We reach to this situation. String breaks. So tension is 0. Can I apply the Newton's second law again? So since the particle is moving in this direction, so tension is 0 minus the friction is 4. Mass is still the same, 2.5 times A. So this helps me to find how much deceleration will be produced in the body. So let me use my calculator. Negative 4 over 2.5. That gives me the deceleration equals to negative 1. So this is my acceleration, which is negative 1.6 meter per second square. He did mention the u is equals to 3. So equations of motion comes in action. U is equal to 3 meter per second. Acceleration is negative 1.6 meter per second squared. It comes to the position of rest. So when it comes to the position of rest, your v is equals to 0 meters per second. Three things are known to me. As per the examiner, I want to find how much distance covered by the body. So which equation of motion will be suitable for me? In this case, 2as is equals to v squared minus u squared. So 2 negative 1.6, s is required. V is 0 squared minus 3 squared. I'm going to use my equation solver. And you also use your equation solver to check my answer is, my calculation is correct or wrong. Shift, okay. And then we write equal sign, negative 3 squared, shift solve, and that gives me minus 2.81. So by why I did get negative? No, it's 2.81. Three significant figures. 2.81 meters. We got it. That's the final answer. So, guys, three questions. I put it in 5.1. Then we go to the next unit, which is resolving components of the weight when it is on the slope. A bookseller is delivering some heavy books. While out on her journey, she stops to talk to a customer. As she does, this box containing the books, which has a mass of 200 kg, is at rest on a hill. Given that the force acting on the box parallel to the hill is 407.51, find the angle of incline. So angle is needed to be found. So let me make the inclined plane. So this angle is X. So the box is here. Mass is 200 kgs, 200 kgs. You all remember that the weight component, 200, you need to add 0 because times it 10. Sine of X. And this component, which is perpendicular, it is always 2000 cosine of X, which will be balanced with the normal reaction. Okay, the force which she is applying, that is, given that the force acting on the box parallel to the hill is 407.51. Okay, as a bookseller is delivering some heavy objects while out. So now in this particular case, our force, and she is applying a force in the upward direction for not letting it go down. So she is applying 407.51. Clear? Now this force should be equal to 2000 sine of X. A bookseller is delivering some heavy objects while out her journey, which stops to talk to a customer. Okay, done. Which has a mass kg, is rest on a hill. So it is not moving. He didn't talk about the friction here. She's applying upward, and it should be balanced with 2000 sine of X. And I can easily find the angle, which will come to me, guys, equals to, by using equation solver, your calculator must be in a degree mode. So 407.51 equals 2000. So sine of alpha X, close the bracket, shift solve, and you get your answer 11.75 or 11.8. 11.8. So can you do the correction? Maybe in the revision pack, I have used the value of G 9.8. No, in mechanics, you have to use the value of G always 10 meter per second square. And that's the final answer, guys. Since the block was in the position of rest, so the downward force should be balanced with the upward force. So this is question number 1. Now we go to the question number 2. A truck carrying fruit for a local market down on a hill. Given that the truck and fruit have combined mass 1,500 kg, calculate the component of the weight parallel and perpendicular to the plane of the hill if the hill is inclined at 5 degrees. So as you know, if I'm talking about inclined plane, this is 5 degrees, and we have a mass of 1500 kilogram. The component along the plane, 15, add one more 0 times with 10, and sine of 5 degrees, and this is 1500 cosine of 5. It is well balanced with the normal reaction. Okay, a truck carrying a fruit on a local breaks down on a hill. Given that the truck and okay combined mass, calculate. Just we need to find the components, the weight components. So this thing is needed, and this thing is needed. So the weight component parallel to the plane is 1,500 sine of 5. Okay, and that will give you the answer. And W perpendicular to the plane is 1,500 cosine of 5. So let me use my calculator. What is the answer we are going to get? Three zeros times sine of 5. It gives us 1307. Okay. If you want to write it as three significant figures, you can write 1310. 1310 newtons. And the second thing is I want to find for the parallel 1,500 times cosine of 5. So that gives me 14942, and I'm just going to write 14900. 14900 newtons. Let me check it again. All the answers. Yes, we are done with parallel and perpendicular. A body of mass, a body of mass 10 kg rests on a plane and at an angle of 30 degrees to the horizontal. Find the components of the weight parallel to the plane and perpendicular to the plane. The value of G is 10 meters per second square. So my dear friends, parallel to the plane, just the weight component. The mass is 10, so times 10, so it will become 100 sine of 30, and this is 100 cosine of 30. So the weight parallel to the plane is 100 sine of 30. That gives us 50 newtons. And the weight perpendicular to the plane, it is 100 cosine of 30. And that gives us 100 times square root of 3 over 2. So 50 square root of 3 newtons, or approximately, you can write it as 86.6 newtons, three significant figures. I hope it is clear to you guys. Now we come to the unit number 3, which is multiple forces. So multiple forces, student needs to know how to resolve the forces. So first thing is that I'm going to explain you the particle A and then particle B. Small blocks A and B are held at rest on a smooth plane at 30 degrees. Each is held in equilibrium by the application of force 18 newtons. A force of F A, a force on A acts parallel to the line of greatest slope, and the force B acts horizontally in the vertical plane containing the line of greatest slope. So find the weight of A and the weight of B. Excellent. Masses are not provided to us, but system is in equilibrium. So can I just look at the particle A first? Let me draw the diagram again for you. This is 30. And this is particle A, whose mass is A. Weight component 10 multiply with mass of A and sine of 30 degrees. Agreed. And you are applying 18 newtons upward. System is in equilibrium. And he did not mention any friction over here. Clear? So can I put 10 MA sine of 30 is equals to 18 newtons? So 100, this is 10 MA, it is half 18 newtons. Clear? And then we go to this part when I say that mass is, this is 5 newtons. Yes, this is the mass which is given to us. He said 18 newtons is applied. So 5 MA is equals to 18 newtons. And mass is 18 over 5. But you remember that we need to times with 10. So the weight of A is 18 over 5. This is in kgs times with 10. So my answer is 36 newtons is the weight of A. So weight of A is pretty simple. But if you want to find the weight of particle B where the situation is a little bit different, let me try to explain it. Actually, I'll draw the diagram here for you. Make the inclination a little smaller. Yes. So here we have a mass, and examiner is applying a force here, which is 18 Newton. I'm talking about this. And this is 30. Obviously, this is 30. Can I resolve it? For sure, I can resolve along the plane and perpendicular to the plane. So this should be 18 sine of 30, and this is 18 cosine of 30. So you are applying 18 cosine of 30 upward. And what is the weight component? That is 10 mb mass of the particle B. I don't know what is the mass of particle, the block M, sine of 30. So at this time, I'm going to write this thing equals to this thing, since this particle is in equilibrium. So 10 mb sine 30, what it equals to 18 cosine of 30. So shall we use equation solver? So write 10 times x times sine of 30 equals 18 cosine of 30, close the bracket, shift solve, and then you got your answer 3.11. That is the mass. We got it 3.11 mass MB 3.11. Let me see. Yeah, 3.12 kgs. I need to multiply with the 10. The weight of B 3.12 times 10. So 31.2 newtons is the final answer. Now we go to the next question, number 2. He said that find the value of P when the force is parallel to the plane and the weight is 18 newtons. So mass will be 1.8, weight is 18 Newton. You are applying a P Newton force upward. System, is the system in the equilibrium? Yes, system is in the rest position. So upward force is equal to the downward force. What is the weight component? The weight component has to be weight times sine of 30. So P has to be equals to 18 sine of 30, which is equals to 9 newtons. You can easily solve it. Now, this is the P Newton force, and this is 30 corresponding angles. Can I resolve it? This was P, so I'm going to call this P sine of 30, and this is P cosine of 30. Now, P cosine of 30 will be balanced with mass, weight is 18, sine of 30. In this case, I'm going to write 18 sine 30 equals with P cosine of 30. Use equation solver. 18 sine 30 equals sine P, you will replace it by X in the calculator, time cosine of 30, close the bracket, shift solve, and we got our answer 10.4 newtons. So 10.4 Newton is the value of P we found to the three significant figures, or you can keep it in the third form as well. Now we come to the question number 3. And question number 3 says that the tension in the rope is 8 newtons. First, we need to resolve this 8 Newton force along the plane and perpendicular to the plane. So along the plane, it should be 8 cosine of 10 degrees, and perpendicular to the plane is 8 sine of 10 degrees. Weight component 50 sine of 25 and 50 cosine of 25. Now, calculate how far it will travel in 6 seconds. So it will move from here to here. A particle, a body of mass 5 kg is released from rest, so it slides. No, it is going down. It is going down. Yes, it is going down. So angle is given. It is connected by light inextensible string to a plane. A tension in the rope is 8 newtons. So how far will it travel in 6 seconds? So final stage, it will come to the position of rest. So your V is equals to 0 meters. And the motion is happening in this form. So guys, Newton's second law, this force is bigger because the body is moving downward. So 50 sine 25 minus upward force, I'll take this component. 8 cosine of 10 degrees is equal to mass, which is 5 times A. Let's calculate our acceleration by using equation solver. 50 sine 25 negative 8 cosine of 10, close the bracket, then I write alpha 5 x shift solve, and that gives us 2.65 is the value of the acceleration we will able to find, right? So acceleration is 2.65 meters per second squared. After finding the acceleration, guys, the next stage is I want to find how much, travel, how far the particle will travel downward. So V is equals to 0 meters per second. Time is given 6 seconds. So I want to find S. So which equation of motion? S is equals to ut plus half at square can be used in this case. So SU is, but U we cannot use. We need to write Vt as the final velocity is known. Vt minus, and this is not provided in the formula sheet. So V0 times T6 minus half, acceleration is 2.6 and the time is 6 squared. So let me try to calculate the S. Negative. So why the acceleration came to me positive? Let me check it again. My acceleration is 2.65. Okay, I found it. 50 sine, right? Let's calculate the answer first and then we will see. So 0.50 5 times 2.6 times 6 square, it gives us 46.8. Now, if we look into the situation that our components are, when we applied Newton's second law of motion, it gave us the value of acceleration 2.65. But we did not calculate u. As the u is given to us, if I calculate it again, let me try. It is half times 2.6 or 2.65. What is the value given to us? 2.65. Sorry, guys. That's why the value was not correct, because the value of acceleration is 2.65. Then it is all fine. 47.7 meters approximately to the three significant figures we will get. So Newton's second law was very helpful for us. Now we come to connected bodies. In connected bodies, he will provide us two bodies which will be connected by means of a string, and the string is passing over a smooth pulley. So the first particle, this is 2 kg, its mass weight is acting downward, and the tension T is upward. So the weight will be 20 newtons and the tension T is upward. Acceleration will be A upward. Apply the Newton's second law on 2 kg block. Since the particle is moving upwards, so tension minus 20 is equals to 2 times acceleration. T minus 2a is equal to 20. This is the first equation we derived. Now come to the second particle, which is 10 kg. Now it is going down, so weight is more. It is 100 newtons, so 100 minus tension. So 100 minus tension is equals to 10 times A. So send the T to the other side, so T plus 10A. Now take out your calculators and use mod 5. I think 1 for simultaneous equations. Enter 1, enter -2, enter 20, enter 1, enter 10, enter 100. First answer is 100 over 3, that is the tension, okay, which is equals to 33 point, the value of the tension is, yes, 33.3. And the acceleration, which I have found it is 6.67. Okay, so 6.67 to the three significant figures we found it. Yeah. Now we go to the question number 2, where one particle is on the table and the second particle is hanging. Do we have any friction? Yes, the guy said the friction is 15 newtons. Now, you are applying a tension T. There is a friction of 15 newtons. Ignore this 1.5 G. And mass is 4 kgs. Apply the Newton's second law on this particle. Tension minus 15 newtons is equals to mass 4A. So tension minus 4A is equals to 15. That's the first particle, which is a 4 kg particle. I have created one equation. Now let's talk about this particle, which is 2 kg. Newton's second law, it is going down. So mass was 2 kg. So 20 minus tension is equals to mass times acceleration. So 20 is equals to T plus 2A. Second equation, use equations, simultaneous equation, and go to the calculator. Enter 1, enter -4, enter 15, enter 1, enter 2, and enter 20. You get your first answer, 55/3. Your tension is 55/3 newtons. And the value of acceleration is 5/6 meters per second squared. We are done with question number 2. Now let's go to the question number 3, in which he gives you the value of the mass 15 kgs. And as per the question, the frictional force is 2.4 newtons acting vertically downward, and there is a weight component. Let me show here. That is 150 sine of 30. Tension T is upward. Acceleration is upward. I have shown the weight component. Newton's second law for 15 kgs. Tension minus 150 sine of 30 minus 2.4, the friction, is equal to mass 15 times A. So then T minus 15A is equals to 150 sine of 30 plus 2.4. Okay, so this is your first equation, which you drove from 15 kg. Now let's talk about the 10 kg. I'm not simplifying because I will use everything in the calculator. Now the particle is going down, so 100 Newton down, tension T is upward. So 100 minus T is equals to 10A. So 100 is equal to T plus 10A is the second equation. Copy everything in the calculator. Enter 1, enter -15, enter 150 sine of 30 plus 2.4, then enter 1, then enter 10, then enter 100. First value of acceleration comes to you, the tension comes to you 91 newtons. Let me check that. Are we finding only acceleration? But tension comes to me 90.96. Tension is 90.96 newtons. And the acceleration is going to come to me 0.904. Yes, 904 meter per second squared. That's my final answer. Now we come to the question number 4, boys. Masses are given to me. So this is 0.6 kgs connected by light and extensible string. Initially, P is held at rest. P is then released. Find the tension in the string. It's a smooth horizontal level. So it means the friction has to be, friction is 0 newtons, and you're applying a T newtons to the right, and the acceleration produces A. Clear? And now I'm going to write Newton's second law for 0.6. I'm talking about the particle P. So tension minus friction is equals to mass times A. Tension, I don't know. Friction is 0. Mass is 0.6 A. So tension minus 0.6 A is equal to 0. This is the first equation I got. Now particle Q, whose mass is 0.4 kgs, hanging vertically downward, so 4 newtons downward tension, but the acceleration is downward. So 4 minus T is equals to 0.4 times A. 4 is equals to T plus 0.4A. Now use equations of motion. Enter 1, enter negative 0.6, enter 0, enter 1, enter 0.4, enter 4. And now your final answer for the tension is 12 over 5, which is 2.4 newtons. And your acceleration comes to you as 4 meters per second squared. Now, guys, chapter number 6 starts. I will record this video later. I hope it was beneficial for you, and inshallah, I will share the other videos soon. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.